And we are live. Hello, everyone. Welcome. My name is Britt, and I'm the marketing manager of Eatron Technologies. We're very excited that you're with us today for a second Talk to an Expert. The first one went really well. We had over 200 attendees, and we're going live every last Thursday of each calendar month. So keep your agendas open. If you're not following us yet on LinkedIn, please follow us. And if you miss any of these talks, they're also on Spotify and you can watch them back on LinkedIn, and they're also on our website and you can have the audio version. There's many ways you can listen to these talks. So for those who don't know us, Eatron is an international technology scale-up dedicated to making software-defined vehicles a reality for OEMs worldwide. We develop and license intelligent production-ready software solutions for the automotive industry and mobility. In case you're new here, our house rules, if you have any questions throughout this talk, please pop them in the chat, and our very first expert, our second expert, Kemal, will answer them at the end. So today's expert, Kemal, our AI and machine learning director, can you please introduce yourself?
Sure. Thanks, Britt, for the very nice introduction. Hi, everyone. Very excited to be here. My name is Nazim Kemal, and I am the Director of Artificial Intelligence and Machine Learning at Eatron Technologies. So basically, I oversee all the AI-related operations at the company, including software development and algorithm design. I got my PhD from MIT in 2015, and I've been working on autonomous systems and artificial intelligence more than 10 years at this point. And besides my duties at Eatron, I'm also a professor at Istanbul Technical University in the Department of Artificial Intelligence and Data Engineering, and I'm truly looking forward to this event and answering your questions.
Oh, thank you so much. Well, let's start straight away. AI is such a popular topic today, and I just wanted to ask you, what does AI solve, and why do we need it in general?
Okay, so that's a great question because AI means a lot of different things to a lot of different people. But to me, AI is basically data-driven automation. So basically, if there's a process, a task, or a job where you need to take a look at a bunch of data, and based on that, you need to do some predictions or take some actions. So that is something that you can use AI algorithms to automate. And sometimes this task can be very straightforward, very simple, just like, for example, looking at a picture and telling that if that's a cat or a dog. Or sometimes it can be something very complicated, such as, autonomous driving, right? Trying to navigate a car in a busy street where there are lots of pedestrians, lots of heavy traffic. So the nice thing about AI is it is it's very general. It can be applied to all kinds of data-driven decision-making problems. And we had tremendous breakthroughs in the last couple of decades in terms of how much data we can collect and how we process it. And because of that, we are also seeing a lot of interest and a lot of applications of artificial intelligence to automotive as well. And I believe we are just at the beginning of this story. And I'm very excited to be a part of that through our work in Eatron.
Oh, thank you. So Eatron are very well known for automotive safe AI applications. Can you tell our audience how we apply Eatron's automotive safe AI techniques? I know we have two applications, one being motion and the other being battery management system. Shall we start with motion control?
Sure. So motion control is actually a part of a larger technology that we call ADAS, which is basically autonomous driving related technologies. So the basic idea behind motion control, which is just suspension control actually, is the motion control of the car, it should adapt to road conditions. So basically, if the road you are driving on, if it's a bumpy road or if it's a smooth road, you can actually select different motion control settings and let your car adapt to the conditions of the road. So which would actually improve the safety and comfort of your driving. So classical motion control systems are actually mostly manual. Like you need to select what kind of motion control performance you want from the car. But at Eatron Technologies, we are actually taking this one step further. We are using state-of-the-art AI-driven perception technologies where we can actually look at the road through our cameras, and we can actually detect whether the road is bumpy, whether there are cracks on the road, or whether the road is really smooth. And based on that, we automatically change the parameters of our motion controller so that they can adapt immediately to road conditions. And when you are driving the car, it feels great. You don't even you can't even tell the difference if it is actually a bumpy road or a smooth road. So yeah, that is the basic idea behind our motion controller.
Okay. Could you please elaborate what makes it difficult to apply AI in motion control?
Yeah, well, actually, not even specifically motion control. Whenever you are trying to design and deploy AI systems for automotive, there's always a huge challenge in verification and validation. And we also face that same challenge in motion control as well. Well, you cannot just train an AI algorithm on your workstation and then deploy it on the car and hope that it works great. It doesn't work like that. So
Okay.
in Eatron, we have this very elaborate scheme of continuous verification and learning. So, and it actually starts in our simulator. We have our own custom simulator where we simulate millions, billions of different scenarios, different road conditions, different traffic conditions, and everything, where we can actually spot some of the failure cases before we actually even go to real road tests. And then we automatically fix actually most of these mistakes by retraining our algorithms or collecting more data. And after we are confident in the performance, we would go and do real road tests. And then we would also learn from these road tests as well. So like I said, this is just like a huge continuous cycle of learning and improving. And I think this is why we are calling algorithms that we develop at Eatron are safe AI algorithms, because they go through a very rigorous and elaborate verification and validation process.
Thank you. That's really exciting. For anyone listening, we actually have demo cars in Warwick, one of Eatron's offices. We have videos of those coming very soon. So we know that batteries are the most expensive item in an electric car. And last month with Christoph, we spoke about the advanced BMS, and a part of it was AI. Could you please elaborate a bit more on that AI and battery management system?
Of course, we are actually doing a lot of cool stuff with applying AI to batteries. One of the technologies that we are really, very excited about is the remaining useful life prediction. So the batteries in your electric vehicle, I mean, of course, you charge them all the time, but they are not going to last forever. All batteries age, and eventually they become unusable. And it is really very important to predict when that time is going to come, like when this battery is going to, reach end of its life, so that you can actually change it, and you don't run into any trouble. And if you are using very simple algorithms to predict that remaining useful life, it will usually be off by weeks, days, sometimes even months. So because actually that remaining useful life, it actually depends on a lot of different things. It depends on your charging schedule, like how often do you actually charge your batteries. It depends on your driving style. Like, I mean, are you an aggressive driver or are you more like a smooth driver? It depends on the chemical structure of the battery. It depends on a lot of things. So the algorithms that we develop takes all of these things into account and give very accurate predictions for whether your battery is reaching its end of life or not. We are really proud of that algorithm's performance. And other than that, we also have some amazing results in battery diagnostics. So even a battery doesn't reach the end of its life, sometimes it can malfunction, right? I mean, sometimes it just breaks down, and that can cause real trouble. Like if you cannot detect battery malfunction early, this can even lead to accidents. Your batteries might catch fire, so a lot of ugly things can happen. And the current systems, they can detect some of these malfunctions, but they usually detect that right before something bad is going to happen. So that is what we call reactive diagnosis. So the algorithms that we develop at Eatron are more on the proactive side. So we try to actually catch all of these faults and malfunctions before it actually leads to big disasters. So basically, our algorithms can identify the batteries that are going to malfunction much, much early than an accident can happen. And then they immediately tell you that, this battery, there's something wrong with it. You should go and check it out. There are also a lot of other, projects that we are developing in battery AI, but I would say that these two are the main ones.
Okay, thank you. Could you elaborate on the difficulties of this one?
Yeah, the most difficult thing about developing artificial intelligence systems for batteries is, I would say, lack of data. Because, like I mentioned, some of the events that we are looking for, like battery malfunctions, like batteries running out of charge, they are aging, so they are nearing the end of their life. So these are not events that you can simply find open data sets on internet. So it's actually very difficult and expensive to collect this type of data, and sometimes it is downright infeasible. But what we do at Eatron is we do not 100% rely on data. We also use a lot of physical models. So our actual AI algorithms are kind of like hybrid algorithms in that sense. We are leveraging both physical models and data-driven models. And I believe that is one of the things that really makes Eatron special, because, I mean, not everyone in the team is a pure computer scientist. We have a lot of people coming from classical engineering backgrounds, such as mechanical engineering, aeronautical engineering, like me, and electrical engineering. So we love AI, but we also love physical modeling and dynamic models as well. So basically, we are leveraging best of both worlds to deliver very accurate predictions in our better AI products.
And then how do you test it before you bring out this product?
It is actually very similar to the cycle I mentioned in motion AI. There's a lot of simulation. So that is another great thing about having models, because you can simulate a lot of stuff. So in the early phases, there's a lot of simulations, but then we, of course, go to real world tests and collect real world data to validate it. And then, the cycle continues.
Okay. Well, we've nearly reached the end of this talk. Is there anything you'd like to mention before?
Well, I would like to, talk to audience and say that we are always hiring. We really love working with people who are passionate about AI and automotive. So, if you are interested in applying state-of-the-art artificial intelligence methods to real-life automotive problems, then please reach out to us. We would love to hear from you.
Thank you. Well, audience must be very excited. So if you have any questions, please pop them in the chat. Kemal will be more than happy to answer them.
Sure.
Before we get to that, I was wondering what you think where AI is going in the future.
Well, that's a very difficult question, right? Because future is usually difficult to predict. But based on my experience, I can say that the automation enabled by AI, it is just going to increase across all different sectors. Right now, it is really popular in some sectors, such as autonomous systems or robotics, like the projects that we are working on. But I think it is going to spread in an exponential rate to all the other fields as well. For example, law, medicine, financial applications, retail. So all of these are going to see great benefits from applying AI. And I think AI is going to become a very standard tool in the toolbox of all engineers. So that is my, rough prediction about the future.
Okay, thank you. Well, everyone, this was the talk. So if you have any questions, we have 15 minutes left to answer them. And with Kemal's background, I'm sure that he can answer all of them. So please pop them in the chat. Let's wait for people to type.
Sure, no problem.
I'm sure they have so many questions that they don't know which one to start with.
Yeah.
Oh, we've got a question from Annette. When will we start seeing AI in serial cars?
Okay, so we are already actually seeing some parts of AI in serial productions. For example, some of the perception systems and some of the automated driving systems, they are actually enjoying some AI technologies, especially the car in the United States, because the regulations are a little bit looser there. But I believe in the next 5-10 years, of course, it's always difficult to pinpoint an exact time. We are definitely going to see much more, automation in cars, both in perception and decision making. So I believe we are right in this sweet spot right now. Everything is going to blow up in the next 5-10 years.
Thank you. We've got another question from Gareth. To validate AI for the road, how much real-world testing and how much simulated testing would you expect to be needed?
Wow, that's a great question, and it is not an easy one, because sometimes it is difficult to quantify. How do you measure time in simulation? If you measure it in simulated time, I would say it is like millions of miles, millions of hours in simulation, because in simulation it is not in real time. But if we are thinking about actual time spent in the world, I would say that it is roughly equal, actually. So, but the good thing is simulation actually saves you a lot of time in real tests. So this is why we really like simulations. We can go and do a lot of tests in real life, without doing any simulations at all. But in my experience, not only in automotive, but in working in a lot of different AI applications, I can say that if you have good simulation tests, that actually cuts down the number of real-world tests that you need to do by a factor of 10, I would say.
Oh, okay, thanks. Christoph, is there any safety challenges involved in deploying AI?
Oh man, so many challenges regarding safety. And safety in automotive AI is really really important, right? Because, for example, in most AI applications, safety might not be that important. For example, like I said, if you are looking at an application where you need to classify whether this picture is a cat picture or a dog picture, you can be wrong 10% of the time, and it wouldn't matter, right? Of course, it would matter if you are paying for it, but it wouldn't cost any lives or something like that. In automotive, even small, errors can actually lead to very bad results. So we need to be aware of safety when we are deploying AI in automotive. And I would say the main challenge is, again, verification and validation of the safety of your algorithm before you go and deploy all these things on the road. And like I mentioned, our main approach to that is basically adaptive verification, I would say, adaptive simulation. So we do not work with a fixed test cases. So we do not only test our algorithms on 100 test cases or so. Our simulators, they actually discover a lot of test cases on the fly. So they continuously try to break down our algorithm. This is why we are actually validating safety across millions of different test cases, so we can actually identify the ones that we need to fix. And once we do that, and on top of that, of course, we do real-world driving tests, then that is how we ensure our algorithms are safe.
Thank you. I hope that answers your question, Christoph. Emmanuel says, could you please tell us more about the process to collect data needed for using AI for BMS? Is it needed a campaign of tests?
Yes, that's a great question. Like I said, that's actually a big challenge when you are developing AI systems for batteries. I would say that the first part, when you are developing the core algorithms, it is based mostly on simulation and some data sets that you can collect from open sources. But then, of course, this is only the beginning. Then you really need to collect some real-world data and validate your algorithms. One thing we are doing, we actually have a lot of partners who are working on better experimentation and data collection. So we actually partner up with them. We give them specifications on what kind of data we need, and of course we also get data from our customers as well. But it's a really exhaustive and difficult process collecting data for BMS applications. It takes a lot of time. It takes a lot of effort. But once you get everything in place, especially if you support that with simulation data, and by simulation, by the way, I'm talking about not some simple equations. I am talking about really high fidelity physical models that can actually simulate a lot of battery dynamics in the cell level. So once you actually put all of this together, that is where you start seeing real accuracy, and that is where you start to see real performance. So I hope that answers your questions, Emmanuel.
Ali says, can you shed some light on explainability? Greetings from your ex-students at ITU.
Hi, Ali. Explainability. Well, so explainability is a very popular topic in artificial intelligence, right? And because as most of the machine learning algorithms, they are what we call black box models, in the sense that they make some predictions, but they don't tell you how they arrived at that prediction, right? So for instance, let's talk about remaining useful life prediction. So our AI algorithm will tell you that, hey, your batteries are going to be useless in a month. Okay, so they tell you that. And then you might wonder why, what's wrong? And they can't tell you anything about that. So this is how classic machine learning works. At Eatron, actually, we try to push this a little bit further. We try our algorithms to be more explainable. So, of course, we don't have definitive results on that yet, but we are working on it. But one thing we are leveraging is, like I said, physical models, because physical models are more transparent. They are actually more white box than black box compared to fully data-driven models. So we are hoping that in the future we will actually have algorithms that can make predictions and also explain that how they arrived at that prediction. But it's a very difficult problem, I need to say. I mean, there are almost no major technologies on these topics. Not a lot of people can do it.
Thank you. Oh, I think I missed a question from Deepak. He says, can you please explain how AI will play an important role in BMS? Will AI boost battery swapping?
Well, if by battery swapping, you mean that by using AI, we are going to have more efficient battery swapping procedures? Kind of, yes, because, for example, the remaining useful life prediction problem, if you can get accurate predictions, then it will actually kind of give you an optimal time to switch your battery. And as a result, basically, your car will be healthier. Your overall performance of the car will be better. So basically, it will boost the efficiency of electric vehicles because we can maintain the batteries much better. The same with the diagnostics. If we can actually diagnose there's a problem with your electric vehicle as early as possible, basically we will save you a lot of money, and hopefully, we will actually prevent from a lot of maintenance fees and stuff like that. So overall, if you are using AI-driven BMS systems, basically you will get more out of your electric vehicles, and your money will be better spent. So that's how I can summarize it. Yeah.
A LinkedIn user is saying, is preventing accidents with the help of AI possible, and how can we verify the safety aspects of this feature?
Absolutely. So one of the main benefits of AI is, given that it is working, given that it is working correctly, AI can actually process data and give decisions at a much higher rate compared to humans, right? Because as humans, we get distracted. We cannot really process high volumes of data. We can only, pay attention to a couple of things at a given time. Algorithms doesn't suffer from these disadvantages. An AI algorithm can process, lots of information. And because if it was trained correctly on a large amount of data, it will always try to give an optimal decisions, something that is more efficient than a human user. And so that basically means that if everything is done correctly, an AI-driven algorithm should be always more safe than a human driver, whether it's an autonomous driving scenario or whether it is some kind of other applications. And how can we verify the safety aspects? Well, like I mentioned, there is no easy way to do that. It is really a mixture of a lot of offline simulation tests and online real-world tests. Like I said, it is an adaptive, continuous process that we are actually just figuring out now. So verifying safety and robustness of AI applications, that's a very new topic. And of course, at Eatron, we are working on it, but also a lot of other people are working on it. So I believe safety and verification, validation, all of these things are going to be, very popular and trending topics in AI automotive in the upcoming years.
Thank you. Siva Kumar is saying how AI will be effectively used for adaptive BMS, please.
I am not sure what you mean by adaptive BMS, but if you are, maybe if you can detail the question a little bit better, I can answer it better.
Okay. Christoph is saying, what advice would you give to students graduating and starting their career in AI?
That's a, yeah, that's a great question. Well, what can I say? Well, there are so many things you can say. I am trying to, think of which ones should I say first. But the first thing I should say is, there's a lot of hype surrounding AI, and sometimes people get fooled by the fact that you can just, go and watch a tutorial, download some codes, press play, and get some results, and suddenly they think that AI is easy. Oh, I have now learned how to do an AI. So there's a lot of, false confidence in people who are starting to do this. But if you really want to be a good AI engineer, you actually need to have a solid background in mathematics, especially probability theory. If you are going to work on, automotive applications, you also need to have, a very good background on physical systems, dynamical systems, and modeling as well. So I would say that really pay a lot of effort to learning fundamentals of statistics, machine learning, and optimization, and also learn fundamentals of physics and dynamical models as well. In the long run, this will really pay off, and you will be a much better engineer and much better practitioner compared to people who just watch some videos on YouTube and just download it and practice some codes. So that is what I would recommend to people who are starting out. And second, I think I would recommend is try to join a company who are working on exciting things and state-of-the-art applications, especially startups, because I believe startups are a really great learning opportunity for people. Sure, there's a lot of work to be done, but I mean the best place to learn something is a place where there's a lot of stuff going on. There's a lot of development and exciting things. So this is why I recommend people to join startups at the beginning of their career, so that they can really experience working on high volume and interesting stuff.
Amazing, thank you. Atakan is saying, what kind of cybersecurity precautions are being carried out in autonomous driving and ADAS?
That's a very interesting question, and that's actually a real concern because for the audience members who are not aware of it, it is possible to hack, self-driving cars, and that sounds actually kind of scary because if you can hack a self-driving car, you can take control of the car and you can kidnap the person or cause some accidents. So these are some real concerns. But having said that, a lot of actually people are working on this type of problems to develop cyber security applications so that these cars cannot be hacked, easily. And I believe right now it is not really easy with the current systems because of the advances in cybersecurity. I'm not an expert on that subject, so I'm not going to, go into details. But just let me say that yes, it's a real problem, but a lot of people are working on it, and I believe it is getting better every year.
I'm sure we'll cover it in one of our talks soon. Azad saying, greetings. What skill do we need to have to be part of the AI department at Eatron?
Okay, good. Well, first of all, I would say that, of course, you need to have a solid engineering background. I would say we really want people who are going to work at Eatron to have a solid understanding of the fundamentals of, artificial intelligence, basics. So the things that I just mentioned, for example, probability theory, optimization, basics of machine learning, we really want people to have a good grasp on that. But beyond that, we really want passionate people. So people who actually comes across as very passionate and dedicated to what they are doing, they are the people who we usually end up hiring. So, like I said, have a solid background on fundamentals, and also be very passionate about applying AI to automotive. So that is, the tips I can give.
Thank you. I'm sure they're very helpful. Um, Yogesh is saying how AI can be used for prognostics and how Eatron is leveraging it in BMS applications.
That's a great question. I tried to actually explain that a little bit at the beginning of my talk, but basically, what we do is again we have a simulation system, and also we have real data where we can actually simulate a lot of battery faults, battery breakdowns. Okay, so then basically we can train a model on that data. So whenever there's an anomaly in the battery signals, like whenever there's something going wrong, we can immediately tell that, hey, this battery is not behaving normally, because we know what a normal battery looks like, because we have trained millions of samples from normal
Mm-hmm.
batteries. We trained our algorithms on that. So whenever there's an anomaly, we can immediately pick it, and we start paying more attention to those signals. And eventually, if we can confirm that, that battery is behaving in a not normal manner, then we basically provide a warning to the user saying that, hey, something might be wrong. And it's a really challenging problem, because if you don't tune your algorithm carefully, you end up actually giving a lot of false positive signals, and that is something you do not want. You do not want to tell the user all the time, hey, something might be wrong, something might be wrong. You don't want to do that. But at the same time, of course, you don't want to let go of a faulty battery. So it's actually it requires a lot of expertise to fine tune it carefully. But that's our job. That's what we do at Eatron.
Thank you. There's a lot of questions coming in. We might go a bit over time, if you don't mind. Is that okay?
I don't mind.
Okay,
Let's answer the
thank
questions.
you. um, Becky, could you please elaborate a bit on your question? I don't really understand what you mean. Siva Kumar has given a bit of an insight of what they meant. Let's see. So how AI will be effectively used for adaptive BMS, and they mean adaptive BMS is updating the software calibrations using logged vehicle data to improve the accuracy
Oh,
and
okay,
performance.
okay. Now I understand. Now I understand it better. So yeah, basically, so whenever we deploy an algorithm on real world, when then we start actually getting real world data. Basically, one major thing that we take a look at is, did we get the expected performance? Because in simulations, we obtain an expected level of performance, and the one thing we immediately monitor is, are our predictions are within the expected interval? Like, are the algorithms behaving like we expect them to do? And if they do, that is great. It means that our system is working. But of course, in the first run, that is not going to be perfect. So we try to actually find data points where the algorithm is not actually doing what we expect it to do, and then we immediately go back to our training and tuning process, where we re-evaluate the algorithms, and we actually tune everything so that next time we deploy it on real life, then those data points will also be clean. So this is basically how we adapt the process. So I believe this is as basic I can I can go in terms of, this is the most simplest form I can explain how this process works.
Thank you. Halil was saying, how will AI models improve when the new problems are encountered? When new problems are encountered.
Well, I mean, it is basically like I just mentioned. So whenever we identify a failure scenario, whether it's in simulation or it's in real life, well, there are usually two things you can do when it comes to fixing that with AI. You either lack data, so you need to actually retrain your algorithm on those failure cases, and hopefully it will improve. Or basically, you need to tune the parameters of your algorithm so that it can actually correctly identify what is the problem with that data point and hopefully fix it. It is really problem dependent and case dependent. There is no like a general solution that can fix everything. But those two are the main strategies, I would say.
Iroa is saying, comparing the test in real life against the test in simulation, what challenges do you see in real life from AI point of view?
Well, yeah, like I mentioned, when your algorithms don't work as expected in real life tests, that's a big challenge. I mean, that is the biggest challenge, because you cannot simply train algorithms only on real world data, because that is infeasible, right? You cannot test your vehicle in millions of different real world scenarios. That would be infeasible. I mean, and it would cost you a lot. So what we do instead is, once we identify what is not working in real life, we actually go back and we actually adjust our simulators. We adjust our training process and everything. So basically, our simulator starts to look more and more like real life as we collect data from real life. Whether it is, the traffic dynamics, or whether it is the road conditions, etc. So basically, all of our simulators are actually adaptive simulators. And actually, we published a lot of papers on those things too. So it is not completely a secret. Please go to our website and check out our publications, especially the ones we published at Intelligent Vehicles Conference. You can see, some details regarding our methodology there.
Thank you. Arda is saying, in case of an accident, how do you decide whether the accident occurred due to software or data error?
That's a great question. And again, there is no straightforward method to answer that question. But usually we have a lot of advanced debugging tools that can tell us that whether it was a software error or not. So before we deploy everything in real life, we do a lot of hardware in the loop tests. So if there is a software error, usually it will show up in our hardware tests before we go on real life tests. But if we are completely sure that it is not a software error, then usually it can be an algorithmic error or a data error. And in that case, if it's a data error, for example, we can take that data and we can simulate the same scenario in simulation. If we run into an accident in the simulation too, that means that it was an algorithm problem or a data problem, and then we look for ways to fix it.
Thank you. As I'm saying, I will definitely apply for a position. Well, that's great. Exciting. Yeah, please do. Guru, do you have a recorded video? Oh, yes, it will be when this ends. You'll see it on LinkedIn, and then by tonight it will be on Spotify and YouTube as well, so then you can see it back. I guess we'll answer the last few questions now. Azara is saying how AI helps to validate CAN protocol for automotive vehicles.
Well, I would say that those are different problems. Like the problems that I mentioned today are mostly related to ensuring that the algorithms work correctly and algorithms actually work efficiently in real life problems. What you're referring to is more like a hardware, software verification type of problem. So it's a little bit of out of scope. But I'm sure our software engineers would have, better answers to that question. Maybe some of them will comment on LinkedIn, answering your question.
Thank you. Atakan, we have Kemal has already answered your question about cybersecurity. So I guess watch it back and then you'll see his answer. Thank you, Annette, for your support and answering the question. Well, that was all the questions for today. If you have any more, please pop them in the chat, and then one of our Eatronians or even Kemal will answer them. And then, so thank you so much for today, and I hope to see everyone in the next one. And Mary's. Do you have time for one more question?
I do. I don't mind. Yeah.
Yeah. Okay. You said that AI will be a tool every engineer can use. Can you give advice about how to learn AI, where to start, and the skills you recommend to have?
Well, like I mentioned, if you are already, a college student, if you are already at the university, make sure that, the fundamental mathematics courses, make sure that you master them perfectly. Linear algebra, probability, optimization, statistics. So all of these are very important. So the first step actually is learning them. And after that, if you can take machine learning related courses in the university, go for it. But there's also a lot of great online courses as well. You can just Google them and find more about this. And maybe the final piece of advice would be practice. Make sure that you practice on a lot of applied projects. There are a lot of great open resources on internet. Make sure that you practice coding, work on real world data sets. So these are some basic advice I can give you. And maybe later you can join a lab in a university to develop your skills further, or you can apply for a job. So That's the best advice I can give.
Well, thank you. And thank you everyone for joining and for commenting and asking all the questions. We really enjoy answering all of them. Whoever wants to apply to work at Eatron, please, go on the website and apply. We're always hiring. And Kemal, thank you so much for today. I've learned a
Thanks a
lot.
lot, Ruth.
And see you all soon.
Thanks,
Thank you.
everyone. Bye.
Bye.